Hi everyone, welcome back to my channel. In today's video, I will try to show you or explain how convolutional neural network is working. So the powerful model are specifically designed to process and understand images and making them, let's see, this is the CNN is the core of computer vision and it's used for anomaly detection, autonomous driving, medical images, and many more applications. So this is, let's see, this is, architecture of the of the CNN, and this, of course, I will explain this in a very more details in the next coming videos. But this is only an introduction to CNN. What is the CNN and how is it working and when we need to use it? And before diving into a CNN, let me just let's us firstly understand what is an image. And an image is essentially is a grid of pixels. Let's say, for instance, two-dimensional matrix, just for simplicity. And each pixel represent a specific color. And as you can see, let me just zoom in. And if you see here, this is, for instance, this is the region or this is the circle. It's of course not only one pixel, it's many pixels because it's a small image. But if you can see pixel, it's like only one cell. And as you can see, for instance, for color images, we have red, green, blue, or RGB. And each pixel in each channel represent three numbers. Each pixel it represent three numbers, and it is the intensity of red, green, blue. And you can see, for instance, as you can see here, this is, for instance, this is the pixel value after, let's see, the normalization. So the color image, the intensity, or let's say the values of image, the normal one, it's from zero for each channel from 0 to 225. But this is a sample of after normalization. So it's like the value of pixels will be between 0 and 1. This is only to show you how is it image represented. And you can see, for instance, here red, green, blue, and it has now three channels. And let's go back to the image, our image here. And you can see here, this is the color image, and I try to split each color, each channel in a separated image. And you can see this is the red image. If you extract only the red image, the first channel, it will be like this. It's a green image. But if you would like to add some colors, it will be, of course, red. I mean, to make it as a color image, it will be red, for instance. And this is the green, and this is the blue. And now, and you can see, for instance, let me just forget to add this to mention this. Here's, for instance, red, green, blue. If the three pixels, the three values in one pixel, let's say in the three channels, for instance, if you see, for example, if you select this pixel here, and this pixel is 0, and this one is 0 in the green color, and this one in the 0, this will be black. You can see it as a black color. And for instance, you can see this red because it's 255 and the other one is 0. And blue, there's the blue, no, there's no blue. And it's just only, let's see, this is the representative color. And this colors is from 0 to 255. For instance, this could be 100, 100, 100, 120, 120, 100, 255. It depends. And there's no, let's see, it's not, let's see, mandatory that the sum all of these values will be 200, 255. No, as you can see here, for instance, 200, 255, 200, 255. And this is this is the black one, and this is the white color. And let's see why we are not using the neural network, traditional neural network. In the previous video, I have explained how to calculate the parameters of the neural network. So if we would like to use an image for the traditional neural network, first we have to flat the images into one single dimension. For instance, as you can see, for instance, I have this image 224 and 224 multiplied by 3, let's see, three channels, weight width, height, and channel. And we need to flat all of these pixels in this one image, in this one image. And you can see here is 150 value for only for one image, if we assume only 224. Now we will, if we, let's see, flat these images, we will lose the spatial relationship between pixels. For instance, this pixel, it will lose the I mean the spatial relationship. For instance, let's see, this is the image, and the second image, for instance, from here, it will be down here, and there's no relationship between these pixels. And no, now we will figure out that we need a huge number of parameters, and this will make us slow, and maybe we need a high computer just only to run a few images, a few layers. And let's see, assume, just to prove that we need a huge number of parameters. This is, I'm just flattening all my, I mean, the image that I have, this one here, in one list. Let's see, in one dimension, and I have this, for instance, 150 pixels or value. Now I just assume that I have one hidden layer, one, and this hidden layer, it has eight, 1 2 3 4 5, no, six neuron, let's see. And to calculate these parameters, I already, as I mentioned in the last video in more details, the number of parameters in each layer, in this layer here, for instance, it will be n plus 1 multiplied times m, and n is the number of neuron here. So you can see here's 150 plus 1 multiplied by m, where m is 6 here. So for this layer here, we will have almost 1 million parameters. Let's see, 900 parameters, 1,000 parameters. That's why we can't use neural network for this region. For this, now we need, why we need to use CNN. For CNN, we will try to use a small filters. It's called filters or kernels, and it will move to the as a sliding window to the across the image, detecting local features like eyes, corners, textures, and this I will show you in a more details. This is only, let's see, an introduction to the neural network, CNN. And as a parameter, it's more efficient because we are the sharing parameters, the weights are already shared across all the image. And let me just show you this here. What are the main component of the CNN? It's a convolutional layer. So this detects the basic features like edges, vertical or horizontal edges, texture, and etc. Now, how is work? So filters 3 by 3 slides over the window. For instance, let me just move to this. So assuming this, I have this image here, this red here, and for that I have this filter here. And by the way, this filter will be updated over time when we have a back propagation. So in the beginning, this could be randomly initialized, these filters. The images will stay the same in each iteration. And let's see, for instance, I just because I have 3 by 3, I will just map it to this 3 by 3, and it will be product wise. For instance, 0 times 9 plus 2 times 4 plus 1 times 1 plus 4 times 1 plus 1 times 1, and etc. And this will output only one pixel, let's say this one here. And for the next time, we will try to multiply this pixel with the next region from the image. So this will move from this, for instance, and we will take this region here. For instance, like, no, we will take this from, for example, from here, from this region, and we will include also this. And for the next time, we will do this from here to this. And once we finish this, we will go down when it's one pixel. And so it will be from here and including this one here. And do it again from left to right and then down. This will be explained in the next video, don't worry. Uh, Let me just see. Yeah. And the output of this multiplication of convolutional neural layers, it will be this one here, which is called feature map or output map or feature map. It's called the scientific. Now we will see this is the first component, convolution layer, and of course the kernel, of course. So we need also the kernel to learn these features, to extract this feature, for example, lines, curve, textures, and edges, and everything. And as I said in the beginning, filters will be updated over time with the back propagation. And as I mentioned in the beginning, we will, because we will see an introduced number of features. And as you can see here, I have 9 features here, for instance 9. And this 9 will be shared all for all the image. And I will use the C, for example, for the H ebook or H forward. I will use this filter for the whole image. So it means I'm sharing the weight for the whole image. So that's why we need to let's reduce number of weights. Now the activation function, after calculating the after computing the, let's say, the feature map, I'll just add a random example here. And the activation function, let's say I'm using ReLU. And ReLU, it adding generally activation function adding non-linearity to the network, so that it can learn many, let's see, more complex patterns. And for the ReLU, it will activation function. It will reduce. Let me replace the non-positive value with 0. And you can see here, for example, this is -1, -8, -3. It will be replaced by 0. And if we replace this by 0, we will try to reduce also the computation, because this is almost 0. And for the polling layers, is reduce the feature map. So as you can see, for instance, I have this feature map. This is also taken from this source, and also this one is from this link. And assuming that, let me just, so the polling layers, it's, let's see, I have different polling layers, polling mechanism. For instance, max polling layer, or average polling layer, or maybe minimum polling layer polling. And let's say this in, I'm taking the maximum. And let's say I have 2 by 2, let's see the region. And from here, I will take the maximum one, for example, max polling. And this, I will just take the maximum value from here and put it here. So as you can see, I just reduced 4 pixels, and I just need only one to represent this region here. And for this, for the other one, I will divide the image into grids with 2 by 2 and taking the maximum one. So as you can see, this feature map, it will be reduced to this. And what is the, let's say, the pipeline of the CNN? You have an image, you have a convolution layer, and also the filters. And after getting the output, let's say the feature map, you will do a ReLU plus, I mean, next polling, and also repeating these several layers. For instance, convolution layer, ReLU polling, and etc. Also, you can use dropout, you can use normalization layers. This will be explained in a very more details in the next videos. And I think I think that's it. So if you don't understand, let's see some, this is only a basic. And hopefully you will get, let's see, let's see general idea about this topic. And for the next videos, I will try to explain you, or let's say show you how the convolutional layers is working exactly, with many examples, and with real, let's say, small real examples, and how to calculate the number of parameters in CNN. Yeah, that's it. And thanks for watching. And if you like this video, please subscribe to my channel, like the video, and see you next time.